Good morning, Year 10. Guys, thanks so much for coming. Can I just say, you are the first class for me to be able to see that I've been able to do most of the register before the webinar has even started. Amazing. Thanks, guys. I really, really appreciate it. You guys have done fab. I posted the link for the YouTube webinar. I posted, a link to the YouTube webinar on the Google Classroom. Just need to make sure that we have everyone. Who is T4LLV? I always forget who that is. Natanya, I'll quickly put that on the register. That's great. We're nearly there. I am missing Mary, Ryan, Zihan, and Trina, and Kate. That's Ryan, is it? Amazing. There we go. So I'm only missing literally like 3 people. Zihan, Mary. Oh, there's Mary. Hi, Mary. Good morning. Just Zihan and Kate now, and we're here. Wow, this could be a webinar record. If they get here in less than a minute, then you guys will have set a new record for the fastest register to be done. And I've been doing this a while with my 10s, 11s, 12s, and 13s. You guys could beat the record. Come on. Come on. There's Kate. Oh, one more person. If Zihan gets here in less than 30 seconds, it's going to be a new record. Come on. Come on. Kate, no sorry needed. You're only a minute late. Don't worry. It's fine. Oh, come on. Where's Zihan? Come on, Zihan. Where are you? Where are you? I logged in on the wrong. Zihan's here. What? That's the record. Guys, it is a new register record. That's outstanding. Well done, guys. So good to see you there. Cool. There we go. We're in. Right. Guys, we can crack on. So I set you guys a homework over the weekend. Set it to you guys on Thursday to do relative formula masses. I'm going to share my screen with you guys now. So you guys, and then I'm going to go through the homework. You guys can mark it. And I was here at 3:28. What is that? AM. Oh, share screen. Well, there we go. Look at this. We're on it. I'll get rid of my face. Don't want my face. That is a new record. That's amazing. Love it. Okay, right, guys. So I set you this as a homework of relative formula masses. Our lesson today. Now, guys, just to let you know, if you guys need me to slow down or repeat anything and put it in a more, you meant 8:28. Put to repeat anything a bit slower. I'll try and slow down a little bit today. The great thing is, obviously, this is great revision for you guys because you've done a lot of these lessons with Miss All Day. So it just means that there'll be some really nice overlap and hopefully be able to support anyone who might be struggling a little bit. But I hope you guys got on with your homework. I am just going to quickly remind you guys, do make an effort to fill in the homework sheet. I'll just quickly show you guys the homework sheet. If I can. Let's see if I can quickly show you the homework sheet. This is, guys, it doesn't make any difference to me. You know, if you guys find anything difficult, then I'll do another webinar to support you. If you need me to, I will. So I'm just going to see how you guys have got on, see who's filled in their data. It's always nice to do this with you guys here. There we go. So this is the homework sheet. If you need me to send, oh, look at that. Well done, Year 10. There's only a few people missing. Mary, outstanding, 19 out of 20. That's the best score on there, Mary. I am so impressed. Thank you so much. I know that Oleg is already looking at it, looking to fill in his data as well. I am so, so, so proud of you guys. We had such a great first couple of lessons, and I was so, so pleased with it. Okay, so today we're going to run through the homework, and the next homework, of course, was, and I'll put in here, relative, this is where I need my keyboard. Go on, let me type. Where's my keyboard? There it is. Relative I'm going to put RMM, and then I'm going to put /RFM. It's nice for me to remind you guys, this RMM is relative molecular mass. Now that applies to covalent compounds. So they're ones which are all non-metals. I'll write some of this down for you to make it clearer. And then there's RFM, which is relative formula mass. and this is ionic, but they actually mean exactly the same thing. Yeah, it makes absolutely no difference. We'll add in a little bit more detail here in a second. So this is your homework. So obviously this entire thing is based on the periodic table. Look at how beautiful my table is. Such a beautiful table. This is like the best thing that has ever been brought to science, guys. This is it's just amazing. So we're going to be using that today to be able to do this. And the homework was really lovely because not only does it give you the formula, but it also then goes into words. So it actually will reinforce the first homework that we did as well, which is really nice. Okay, so let's work through these quick as we can so I can get on to the next lesson. So this is fluorine, and it's, of course, these are non-metals. It's nice for me to remind you guys of non-metals. If I draw the line, here's the line. In order to do this line, folks, what you do is you find aluminium. Yeah, find aluminium, and then you start the stairs on top of it. Yeah, that's always how you find that line. So everyone over here, all of these guys are the non-metals. Yeah, all of these guys are the non-metals. And all of these guys are the metals. So fluorine is a non-metal, and it's two non-metals, F2. It's diatomic. Any element, it's nice to add those little bits of detail in. Oh, shrink my pen. So any element, this is an element because it's only made of one type of atom. So this is an element. And the name of this element is fluorine. Fluorine. And any element ending in -ene or -gen, so oxygen, hydrogen, travels around in a pair. It's always nice to know that. They're called the diatomics. So it says calculate the relative formula mass. So by the way, if you guys haven't shown your working, it's definitely worthwhile adding that to your homework for the next time. These come up regularly, you see, at GCSE. So I find fluorine on the periodic table. Yeah, and fluorine is element number 9 and has a mass of 19. Let's show it where it is on the table. So there's fluorine. And the mass, of course, is the top number. So fluorine is going to be 19. I'll just get rid of the 9. Don't need it. But it's in a pair. So we're going to do 19 times by 2. By the way, I am using a calculator for 19 times 2. Don't laugh. I do it because I don't trust my head maths. I've got myself into so much trouble in the past doing head maths. So that's 38. There's our first answer. Tick it if you've got it, folks. Next. Now, iron is, again, it's another element. It's a metallic element. It's one of our metals. And, of course, iron is here. Now, iron doesn't end in -ene or -gen, which means it's not diatomic. This is a metal. And iron, of course, this is an easy one. This here was relative molecular mass because it was covalent. And this one, of course, is just a metal. This is relative atomic mass. So this one was easy, just reading off the top number. So the answer was 56. Tick it if you got it. Next, oh, good old sulfuric acid. I am just going to, by the way, I'm just going to do a couple of other nice things while I'm doing this, which is ones to know and learn. Sulfuric acid, this one here, is definitely, I'm just going to put there, learn that one. Yeah, one of the most important things in chemistry is knowing your acid formulae. H2SO4, I always think it rolls kind of off the tongue. There is a joke that goes with that. I can't remember what the joke is. I've let myself down there, haven't I? Okay, so let's dismantle it. So I've got 2 hydrogens. So I find, I'm going to shrink my pen again. So I've got 2 hydrogens. So H1 off the periodic table, which is here. Yeah, and the top number is what I'm looking at there. H1, but there are 2 of them in it. So times by 2. I'm going to add that to sulfur. Find sulfur on the table. Top number 32. So 32 times by 1. And then I'm going to add that to oxygen. And oxygen we find on my periodic table is 16. I'll clear all these off. Oxygen there, which is 16. I should actually just do this. Oxygen there, top number is the one that matters. So I've got 16 times 4. Total number, if I add that all together on my calculator, 1 times 2 plus 32 times 1 plus 16 times 4, and I get a relative molecular mass. This is RMM because it's covalent. This is covalent because it's all non-metals, and the answer is 98. Tick it if you've got it. Right, aluminium oxide, first ionic to appear, folks. So this is now relative formula mass. Yeah, it's nice to see that, but it makes no difference. We've got 2 aluminiums. So aluminium, we find it on my table. There it is, 27. Aluminium 27, there's 2 of them in it. I'm going to then add that to oxygen, which is 16. We saw that one earlier, times 3. I'm going to do that on my calculator. 27 times 2 plus 16 times 3, and I get 102 for aluminium oxide. Isn't that nice? I didn't know that one. Probably should. It comes up so regularly, aluminium oxide. Right, next one. Again, it's ionic. Just to say, because magnesium's a metal and all of these guys are non-metals. So this is, again, another ionic. It's nice to be able to realize in these exercises, we can go so much further than just doing the exercise. We can talk about the bonding in it. Yeah, so this is an ionic compound, so it's relative formula mass, but it makes no difference. We look up magnesium on the table. So magnesium's over here at 24. Then we're going to add it to, because there's only 1 of them, times 1 if we like. We can do that if we want to be really thorough. And then we can go add. Now, here's the first tricky one. This one jumps a level, folks. Yeah, because now we've got a bracket, which means we've got 2 oxygens because the bracket multiplies everything by 2 because that's outside it. So I now have oxygen, which is 16. You do get used to seeing oxygen a lot, times by 2. And then I'm going to add hydrogen, which is element number 1, times by 2 as well, because that's going to multiply everybody in the bracket. Let's add that up. 24 plus 16 times 2 plus 2 gives me 58. Tick it if you've got it, folks. I like it. And that's a relative formula mass. Next, another ionic appearing. So this now is aluminium nitrate. It's always nice as well to convert from symbols to names as well. It's always nice to practice those. So this is aluminium nitrate. So we've got, and this is again, it's ionic because it's metal and non-metal. So it's relative formula mass rather than molecular mass, but it makes no difference. So aluminium, find aluminium again, was 27, I believe. There it is, circled already. There it is. So aluminium is 27, and there's 1 of those times by 1. And now I go, here's the tricky bit, nitrogen. I'm going to add that to nitrogen, find it on my table. There's nitrogen, and it has a mass of 14, top number. So N14 times by 3. There's the tricky bit, folks. Yeah, and then you go, and then we've got oxygen, which is 16. See that a lot. Now here's the really hard bit. We have a 3 inside the bracket and a 3 outside. What that means is that I've got these multiplied by 3, which means a total of 9. Tricky that. Yeah, level increasing again there. Run that through my calculator. 27 plus 14 times 3 plus 16 times 9. And I get 213. Tick it if you've got it. Which kind of makes sense. The oxygen alone is nearly 100. It's like 151. It's massive. Lots of oxygen in that one. Very heavy. Next. Oh, a lovely one to name. Right, guys, I'm going to put this one on the chat because I think this is a tough one so far. Okay, guys, on the chat, let's see who comes in first. Can someone post me the name of this guy? That's hard, guys. The name of this, I'm going to ask you to name it. And this is a level, technically 6-7. That's where it sits. So what is the name of number 7, please? On the chat, whenever you're ready. Let's see who comes in first. Who's going to come in first? Coming down the line. We've got NH4,2SO4. Ammonium sulfate. Outstanding, Ethan. In a close second comes in Ethan. Ethan's in a close second. Sorry, Ethan comes in first. Zihan in second. Adri comes in third. Ammonium sulfate. Outstanding. Amber comes in a close fourth. Ammonium sulfate. Outstanding. Thanks, guys. Oleg, spot on. Well done, Oleg. Good job. Natanya, Fatima. Look at you guys. Smashed it. And can I just say, I am totally, that's awesome because nobody used the pH. I'm really, really chuffed to bits with that. Kate, are you laughing at my commentary? But that's great. Well done for that. So it is just, and I know that that's going to be tricky, so I'll dismantle this. So in this, we've got this is a complex ion. So we've got NH4, and in this case, it's a plus ion. So this is ammonium. Yeah, and then we've got our sulfate, SO42 minus. And that's a tricky one, that. I've got A-level students who'd misnamed that, folks. Just so you know, I'm really, really impressed. Well done. So this is ammonium sulfate, 2 complex ions. Outstanding, year 10. Well done. Next, okay, so we now need to build its, and by the way, notice, now guys, this one actually stands out as being rather special. The reason being is you would expect this to be covalent because it's all non-metals, but it's not. Just going to add a little bit of detail to this. The ammonium ion looks like, oh, no, that's a fat pen. Let's try that again. Yeah, there we go. So the ammonium ion is NH4, looks like this. Yeah, and it is positive. Yeah, this is a positive complex ion. And the sulfate, wow, guys, I'm showing you a picture here that you'll never, ever, 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 ever have to draw at GCSE, but it is needed for A-level. It's always nice to do that. And so sulfate ion looks like this. This is what a sulfate ion looks like. There we go. I'll actually, just to let you know, the charge is actually on the nitrogen, not that it makes any difference in this case. Yeah, I'm tempted actually just to, I'll do it. There you go. I'll put it in a bracket the way it probably would be, and that's a 2 minus. And then we're going to have another ammonium on the other side. Yeah, there you go. That's what this looks like. Isn't that cool? It's nice to see things drawn out. So it's actually an ionic compound. It's a repeating unit. Yeah, it's a very unusual thing. That just to let you know who owns the charges. The oxygen there has a charge, and oxygen there has a charge. The nitrogen is what's actually positive as well. It's nice just to show where the charges actually exist. You'll never have to draw that. But it's just really, really nice to be able to see it and to understand it a bit more, to understand why an all non-metal compound could be ionic. It's cool, that. Okay, so we now need to give its formula. So first thing is, this is hard, folks. This is by far the hardest for the formula. So we've got 2 on the inside. So I've got nitrogen. I'm going to zoom in a bit. Nitrogen at 14. Let's just check that. Yeah, oh, already done. So I'm just going to clear my table. There's nitrogen at 14. Yeah, and I've got 2 of them. That's the tricky bit because that bracket. Yeah, and then we've got hydrogen. Going to add that to hydrogen 1 times by 8 because it's 4 out inside the bracket, 2 outside. And then we're going to add that to sulfur 32, and we're going to then add it to oxygen 16 times by 4. There we go. So this is ammonium. So I have no idea what that would be. So I've got 14 times by 2 plus 8 plus 32 plus 16 times 4. And I get 132. There we go. Tick it if you've got it. Next. Right. A transition metal has now appeared, folks, on the chat. What is that, by the way, again, just to tell you, by the way, because this is a transition metal, this pushes you also up to a level 7. Yeah. So transition metal, this is actually really hard. There was actually two answers to this, one lower level, one upper level. Let's see who goes on the chat first. Can somebody name 8, please? Somebody name me 8. Well done, Ethan. Look at that. Isn't that fascinating? It's awesome. I've got Ethan. Superb, Ethan. Well done. Ethan, you just got the level 7 answer. So did you, Zihan. Well done. Outstanding. Amber, Bo Yang, well done. Adri, great job. Well done. Really impressed. Yeah, that is absolutely right. Natanya, well done for giving me the 2. Superb. So I'm just going to dismantle that one. So this one contains a transition metal. Whoop, there we go. And it is, by the way, I love the Adri, you put copper, carbonate. Love it. So there are 2 answers here. There is just straight out copper carbonate. That there is a level 6 copper carbonate, level 5, 6. Yeah, level 5/6. And then there's the correct name, because it's a transition metal. You needed the Roman numeral of 2. Yeah, copper 2 carbonate. Yeah, now you guys should have done chemical tests by now. Yeah. Does anyone on the chat like to tell me how you test for a carbonate ion and how you test for the... Let's do it one by one. How do you test for the carbonate ion? So I've got Cu2+ and CO32-. There we go. Yes, we've done it. Well, thanks, Ethan, for letting me know. So how do you test for that ion? How do you test for the carbonate ion? It's nice to rope in a bit because, by the way, my year 10s have already forgotten it. You know, it's so easy to forget your chemical tests. It's why we do it early, so we can redo it later on. We'll redo them with you in year 11 because they're so easily forgotten. I wonder if anybody knows how to do it. How do you test for a carbonate ion? If somebody would like to tell me how to test for a copper 2+ ion, you can do that too if you like. Yeah, I don't mind either one. Dilute hydrochloric acid bubbles. Netanya, superb. Add 2 pipettes of zinc carbonate. Good idea, Ethan. It's not correct. Netanya, outstanding. Well done. Then add lime water. Ethan, your first bit is incorrect, but Netanya's is there. Add acid. That's correct. Yeah, to test with this guy, you add dilute acid. You can actually choose any acid you like. If you actually want to know, the best one, the one of choice for me is sulfuric. It's slightly stronger than hydrochloric, so it means it gives better bubbles, more obvious bubbles. And then you bubble through lime water. Well done, turns cloudy. Great job, guys. Really impressed. You guys really know your chemistry. Really impressed. Well done. Bubble through lime water. Really, really pleased. Well done. And it'll turn cloudy. Yeah, that'll turn the 3rd mark there. Isn't that amazing? 3 marks. Cloudy. Cloudy. Turns cloudy. The test for the copper 2+ ion. Any ideas? There's actually 2. Blimey, it's tricky. Chemistry's hard. You've just got to know all these little bits and pieces. It gets easier, by the way. There isn't as many as you think. People often get really lost with chemical tests, and they're like, but there's so many. There aren't actually as many as you think. To test for the copper 2+, I'll leave that open to you guys. Let's work out its relative, and by the way, it's ionic, so formula mass. Add sodium hydroxide. Well done, Fatima. Well done. Add sodium hydroxide and a blue precipitate. Guys, I am absolutely, wow. Well done. Superb. There's an easier one. Flame test. You'll see a green, blue flame. Yeah, green flame on flame test. But yes, sodium hydroxide. Absolutely. Well done. Really impressed. Right, so copper on the periodic table. Copper is there, 63.5. That's a bit awkward. 63.5 plus carbon. Carbon is a very famous one. You'll learn carbon 12. Yeah, so there's plus carbon 12 plus oxygen 16 times by 3. Put it in a bracket. Total number for copper carbonate. I should know that one. 123.5? I don't know. 63.5 plus 12 plus 16 times 3. 123.5. Whee! Isn't that amazing? I have a couple of... that one comes up so often, folks, just so you know. That's how I know that one. Yeah, it comes up so often, it's in my head. Silver nitrate. Good old silver nitrates. Once again, relative formula mass. Yeah, this is an RFM as well. Well, that one was an RMM because it was no. It's no. Tell a lie. RFM, it's ionic. Right, silver nitrate. So we've got to find silver. Where's silver? Silver's there. Wow, it's heavy. 108. Don't know that one, actually. Surprising. Silver, 108 plus nitrogen. So we've done that guy. Nitrogen, which is 14. We get used to this. And then plus 16 oxygen at 16 times by 3. There we go. Total for silver nitrate, 108 plus 14 plus 16 times 3. And I get to 170. Take it if you've got it, folks. Doing really well. Smashing it. Next, ammonium nitrate. Ooh, so we've got nitrogen at 14 times 1. We've got hydrogen at 1 times 4. We've got then plus nitrogen, 14 times 1 again. Yeah, then plus oxygen, which is 16 times 3. By the way, you could have simplified that. I should have put the nitrogens together, but, you know, just I kind of do it as I read it. It makes more sense to me to do it that way. 80. 80 is my answer. Tick it if you've got it, folks. Next, look at that, guys. Hydrated copper sulfate. Got to know this guy. That guy, whoa, there's one fat pen. Let's try that again. It's blue. Yeah, it's actually very blue as well. It's kind of this kind of blue. There we go. It's a blue solid. Anhydrous copper sulfate is white. Oh, my tablet's doing something funny, folks. We'll see how it does. I might need to just quickly restart it and bring it back. But let's build it. So we've got copper at 63.5. Pick that one up already. Plus sulfur, which is 32. Plus oxygen, which is 16 times 4. Put that in a bracket. Now we've got water. And water, I'm going to do separately. Yeah, H2O is hydrogen at 1 times 2 plus 16. So water has an MR of 18. And there are 5 of them. So I'm going to do 5 times 18. It just makes my life a bit easier. Now, you don't have to do it like that. I'm going to, by the way, I think I know this one at 249.5. I will check that now. 63.5 plus 32 plus 16 times by 4 plus 5 times 18. And I get 249.5. It's one of the ones that comes up so often at GCSE that I tend to just know those ones because it's like knowing oxygen and carbon. Yeah, they get easier as time goes on. It's one to know that, folks. Yeah, copper 2 sulfate pentahydrate. Yeah, you got to know that one. So magnesium is just element, so that's just Mg, and Mg is 24, so the answer is 24. That's nice and easy. Now, do you notice what I've just done? I've just converted the words to the symbol. Now, oxygen, notice, the gen is in a pair, yeah, because all elements ending in gen and ene, yeah, are in a pair. So this is O2. And oxygen is 16 times by 2 because it's in a pair. Oxygen gas has an MR. And by the way, this is just a relative atomic mass because magnesium's an atom. And then oxygen is relative molecular mass because it's covalently bonded because it's in a pair, 2 nonmetals. Next, right, we've got ionic sodium bromide. So now what they're doing, guys, this is reinforcing what we did in the previous lesson. So we've now got to create the formulae from the words. So we've got sodium bromide. So sodium is going to be Na+1. Bromide is Br1 minus. If anybody's wondering how we get that, we remember our periodic table is an amazing thing. +1, +2, +3. This is +4 or -4. And then it flips over. So these are the pluses. Yeah, these here are the pluses. And then it flips and then counts backwards. -3, -2, -1, nothing. It's always good to do that. So we find, what we didn't now do is find sodium. Sodium is here. It's in the +1 column. Yeah, so sodium's +1. Bromine, where's bromine? There it is. And it's in the -1 column, so it becomes bromide. Now we do cross and down. They just make the charges disappear, but the numbers keep. NaBr is my answer. So there's, guys, this is a mark on its own. Yeah, and then we need to work out its relative formula mass because it's ionic, metal, non-metal. And we now go, sodium is 23, Br is 80? Yeah, it's 80. It's down there at 80, folks. Br is 80. So 23 plus 80 is 103. 103? I'm still doing that on my calculator. That's awful. No, I won't do it. It's 103. So the guys, there is a mark for this guy and a mark for this guy. If you've got the formulae wrong, you can still get the number if you show your correct working. Yeah, so just bear that in mind. Next, calcium fluoride, bit trickier. Yeah, calcium is in group 2 of the periodic table, which means it's a +2 ion. So we've got Ca2+. Fluoride is in group 7. Just to show you, it's in 1-. Yeah, now we need to cross and down. So we now get Ca2, CaF2. Yeah. And then we go formulae, so that's 1 mark there, folks. And then the relative formula mass, because it's ionic, is calcium is 40 and fluorine is 19 times 2. We saw that one earlier. Yeah, add that on. No idea what that is. So it's nearly 80. 40 plus 19 times 2 gives me 78. Tick there as well. Next. So then potassium sulfate. Right, guys, it's really nice to level those. By the way, that's an RFM because it's ionic. Yeah, and this is also RFM because it's ionic. Guys, this now jumps you all the way to a level 7-8. Yeah, this is a 7-8 because it's a complex ion. You must learn your complexes. So you have to go K. We find potassium in group number 1, which means it's a +1 ion, K+. And then I've got sulfate, SO42-. Guys, you can't find that on the table. You've just got to know it. Know it and build it. Crossing down, I'm going to now need K2SO41. There we go. 1 mark for that, folks. And then we can say relative formula mass is going to be K, which is 39 times 2. Yeah. And I'm going to add that to sulfur 32. And then I'm going to add it to oxygen 16 times 4. Total number, I have no idea. 39 times 2 plus 32 plus 16 times 4. 16 times 4 gives me 174. A mark for that guy and a mark for that guy. Next, going to give the tick there as well. Yeah. Next, chlorine. Oh, it's an element and it ends in -ene, folks. Yeah. So I've got Cl2. I always like that one. Right, so chlorine is a special one because chlorine is 35.5. There are 2 elements to know on my table which have dots after them on their masses. Chlorine is one of them. It's quite hard to rub all this stuff off with my little pen. Chlorine is 35.5 and copper as well at 63.5. Yeah. If you'll notice, I don't think there's any others on the GCSE with a dot after it. Yeah, so those are the only 2. They're good elements to know. They come up on a regular basis. So this one, of course, is times by 2 because it's in a pair. So I'm now going to end up with a mass of 71. So there's actually a mark for that and a mark for that. Yeah. Next, that's, by the way, that's relative molecular mass because it's 2 non-metals. It's nice to do a bit of a reminder of bonding. Yeah, the chlorine atom, these are both non-metals. Yeah, oh, should try and make them the same size if I can. The chlorine has 7 electrons in its outer shell. Yeah, and of course they both have that same situation, but they both want 8. So what they will do, of course, is they will share. It's nice to see that. There you go. So there's a covalent bond when the shells overlap. Yeah, that's kind of cool. So chlorine traveling around in a pair. Right, we've now got chromium oxide. It's ionic, of course, because it's a metal and a non-metal. So this is our FM, not that it makes any difference. Chromium? No idea. 48 miles away. 52. Titanium's 48. 52. I've got to build the formula first. Chromium is a +3 because it tells me in the compound it's a +3. Oxygen, of course, oxide is 2-. We know that because it's on the periodic table, which is in the -2 section. Yeah, got to know those, folks. So then you're going to cross and down, and I get Cr2O3. Most common thing for students to do, by the way, is just do that. Yeah, it's incorrect, of course. So you get 1 mark for that, and then you get, we now need to build our thing. So chromium 52 times by 2 plus oxygen at 16 times 3. Yeah, let's add those all together. 52 times 2 plus 16 times 3. 152. There we go. Next. Sodium. Oh, it's just a metal. This is just relative atomic mass. Nice and easy. It's not an ene or a gen. So it's just Na. And the answer, of course, is 23. Tick, tick. That's it. Iron 3 sulfate. Hardest one on the board. Yeah, we've got a transition metal with its Roman numeral. So you've got to translate the Roman numeral into a 3. And then you've got to remember your sulfate ion, SO42-. This is a level 8, folks. This is a level 8 because brackets are needed. Cross and down. I've got 2 ions, but then I have to put the sulfate in a bracket, otherwise I'm going to have 43 oxygens. I think most people would figure that one out. It is also, of course, a relative formula mass because it's ionic. Now we've got so the 1 mark for that, folks. 1 mark. 1 mark for that. Oh no, gone Yorkshire. Oh no. I tried to do a Welsh accent. Not very good at the Welsh though. Good iron 3 sulfate. Can't do it. It's really hard, Welsh. So now we're going to build this. We've got iron, which is 56. 56 times 2. Plus. Is it plus? I don't know in Welsh. I don't know. So then we've got sulfur, which has got a bracket in. Sulfur 32 times 3. Yeah, and then we're going to add oxygen, which is 16. You see this often. Times 12. Hardest one on the board, folks, this, and it is last. Yeah. The only thing that would have made that harder is if they'd thrown it in with a hydrated, if it'd been dot waters somewhere. 56 times 2. 56 times 2 plus 32 times 3 plus 16 times 12. Wowza. Whoa! It's 400. Right, guys, let's add them up. Let's add them up for your worksheet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now it switches. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Wow. 20 out of 29. Is it out of 30? Is it actually out of 30? It's amazing. That, Kate, that's an amazing what you've just done on the chat. I love it. Out of 20. Ethan, 29 out of 29. You star. Well done. Super, super proud of you. You're going to make a great chemist. Really pleased. Well done. Guys, if you can fill in that data when you can, that'd be great, and I will get on with my lesson. I've only got 15 minutes left of my lesson to do word to symbol and balance. Wowza. Right. Title for today's lesson, equations. Don't worry about the data. You can put that in later. It's not a big deal. Equations and balancing. So my learning objectives were very simple today. 2 learning objectives. Yeah. Be able to write equations. Write equations. Yeah, it's an A, by the way, able to. That's what A stands for. U for understand, K for knowledge. You haven't filled in the table for the, you haven't filled in the title of the data yet. It doesn't matter. Oh, tick. You're absolutely right, I haven't. There we go. Boom. Zihan got more than 100%. That's amazing. I assume he got 29. Guys, you guys have smashed this. So proud of you. Yeah, great job. So equation, word to symbol. You realize, by the way, that the previous lesson supports this one. Word to symbol equations. Be able to word to symbol equation. Yeah. And the next one is be able to balance. Right. So this lesson's very straightforward, folks. It basically works in questions. So question, and you realize that the great thing is this is not a massive lesson. I'm actually going to send you guys as well, link you to the triple science version of this. The double award is a bit simpler. So I want you guys, here's your first question. That we're going to take let's try and make my pen a bit thicker so you can see it. Yeah. So here's my first learning objective. Convert from word to symbol. Magnesium plus oxygen goes to magnesium oxide, and we're done. Thought I was going to continue there. Right, guys, here's what I'd like you to do. So this is question number 1. All I want you to do is just pause the video and have a go at converting all of these to their symbols. And then we're going to look at the balancing for question 2. So just pause the video and have a go at converting those words into their symbols. Brilliant. So once you've had a go at it, you can unpause it, and here's my answer. So then mg becomes mg. Yeah? We know this. And remember, charges don't exist in equations. They do there is a type of equation called ionic equations, where charges do exist, but this is just a standard equation, which you guys will deal with more than anything else. Yeah, oxygen, of course, is special. It has a gen in it, which means it's diatomic. And then we're going to, now this is the tricky one. You've got to turn the product into a formulae. So we've got magnesium plus 2. And by the way, I can't do this on the line. I don't want to do that. Mg becomes plus 2. O becomes 2 minus. Cross them down, but they vanish. Mg2O2 is wrong. We need to simplify this. Yeah, the numbers vanish. So it just becomes MgO, right? And there's your equation. So we've just done the first step. And you realize that this is not a complicated thing. We've been doing this for the last 2 lessons. Yeah, this is what we've been working. You realize you can't do this lesson without the previous lessons. You need them. Now, step number 2, yeah, is to balance. I don't know why I wrote a 2 up there. Question number 1. Question number 2, now that you guys have done that, you can now have a go at balancing. Now, I just want to make sure that you guys, I don't know, you guys should have already done balancing equations, but I'm happy just to give you a little bit of thoughts on it. Yeah, we know that when you're balancing equations, this is nota bene. Although, by the way, if you like, I'm just going to put note, and I'll put this in a sparkly box. When balancing equations, the only numbers, I shouldn't do that, the only numbers that you can add are in front. Now, can I just point out, I just think that's a whole load of waffle. Just to make this really clear, yeah, if I had A plus B goes to A to B, yeah, let's say I've got this equation, that equation needs balancing. The only thing I can do is add numbers in front. It's all I can do. So I'll give you an example. I've got 2 A's. We divide this in 2. Yeah, when you're balancing an equation, yeah, what you're doing is you're looking like this is a weighing scale, and that the weighing scale pivot, this is a pivot, the weighing scale pivot is at the middle of the equation. And all you're going to do is try and make them add up to being the same thing. Well, on this side at the moment, I've got 2 A's. I'll highlight that. Yeah, I've got 2 A's here, but only 1 A on that side. So the only thing I can do is put a 2 here. I can't put a 2 there. That's not allowed. Hence, in front. Yeah? So the next thing is, I've now got 2 A's on this side. I've now got 2 A's on this side. I've got 1 B on this side and 1 B. So that means I am now balanced. I've got 2 A's here and a B, and 2 A's here and a B. So that is now balanced. And I balance that with that number 2 there. Looks awfully scribbly, doesn't it? Let's try and make that a bit clearer for our notes. Although your notes will probably be better than mine, to be fair. They always tend to be. Yeah. So if I had A plus B goes to A to B, the balanced number, which I will still do in red, is there. There is also, just to let you know, an invisible 1 here and an invisible 1 here, but you don't ever need to write it. Yeah. Right. Let's now have a look at the question. There we go. Right. Year 10, pause the video and balance the equation. Have a go. Okay. Unpause the video when you're ready. Okay. So 1 magnesium over here. And we've got 1 magnesium. We've divided the page in half. Yeah, checking each side has the same number of atoms. 1 magnesium here, 1 magnesium there. I'm actually going to, do you know what? I'm going to do this with a highlighter because I can. 1 magnesium, no, I don't like that. 1 magnesium here, 1 magnesium here. 2 oxygens here, only 1 oxygen there. Right, so what I'm going to do is I'm going to add a big number 2 in front. There we go. So now I have 2. I've now got 2 oxygens there. Right, so the oxygens now balance. but the magnesium's now no longer. If you make a change, you must start again. Yeah. So I've now got one magnesium here, 2 magnesiums here. So I'm going to double that one as well. I've made a change, so start again. 2 magnesiums, 2 magnesiums, 2 oxygens, 2 oxygens. We're good. And there's my final product. Guys, on the chat, can you just post whether or not you managed to balance that equation? That would be great. Right. Question number 3. Question 3. Right. Same thing. What we're going to do, I'm going to give you a word. Well done, Kate, you star. Well done. Well done, Oleg. Fatima, well done. Zihan, well done. Adri, well done. Great job. You guys are on this. Yeah. Next, we've only got 10 minutes left. Question 3. Let's go for, by the way, these are going to get steadily harder. Yeah, these are going to get steadily harder. I'm going to give you another easy one just to reinforce what we've done. Yeah. Hydrogen. No hints there. Hydrogen plus oxygen goes to water. Right, guys? First thing I'd like you to do, step 1, convert to symbol. Yeah, convert to symbol for me. I shouldn't do the arrows. I don't like the arrows. Convert that to symbol for me. Yeah, there you go. I'm also going to make my arrow a bit clearer. Sometimes I like drawing the arrows like that. I shouldn't really do it, but sometimes I just like it. It's pretty. It's pretty. There we go. Convert to symbol, stage 1. And then stage 2 is balance. Yeah, convert to symbol and then balance. I like it. So pause the video. Have a go. Hydrogen. Hydrogen. Oxygen. And everybody knows water. There we go. Right. Step number 1. I like it. Step number 2. Let's balance it. So 2 hydrogens in, 2 hydrogens out. 2 oxygens in, 1 oxygen out. Add a number. There we go. Start again. 2 hydrogens in, 4 hydrogens out. That's why you start again. Add a number. Start again. 4 hydrogens, 4 hydrogens. 2 oxygens, 2 oxygens. We're good. Boom. I love it. Right. And you guys are probably thinking, they're easy. Oh, you just wait. We've got 8 minutes left. Question number 4. I'll leave that one there just for a minute. Question number 4. Right. Let's make this harder, folks. So let's go. Hydrochloric acid plus, this is going to be much, does everything ending in gene has to be in a pair? Yes, Zihan and Een. If you have an element on the periodic table that ends in een or gen, it is in a pair. That's how I teach this. How much easier is that to remember, Z? So much easier. Yeah, have you never been taught that trick before? Great trick. Yeah, you can actually, it's boss. Pair, 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 pair. I'm done. And look, by the way, it actually also spells out a number 7. 7 elements. You never talk about astatine. Yeah, astatine is the rarest element on the whole planet. Only 2 grams of it. We never talk about astatine. We can predict her, but don't really know. It's cool stuff. Great stuff. It's amazing. Let's go back to this. Hydrochloric acid plus, let's go for much. I want to be careful here. I do want to stagger this in terms of level-wise. Let's go for calcium oxide. Calcium oxide, arrow, gives me calcium chloride, calcium chloride, and water. Much, much higher level here now, year 10. Right? Impress me. Convert step A. Symbol me. Symbol me. And then B, balance me. And to be fair, I do need balancing. I'd probably say that I'm a pretty unbalanced individual. Oh, just see what I did there. See what I'm unbalanced. Oh, bad joke. My bad. There we go. Right, pause the video. Have a go. This is, guys, I've just taken you from this is like a level 5, 4, 5, and I've just jumped you up to a level 7. Sorry about that. It's still not the hard as it gets, but it's much harder. Yeah, right. Symbol. I've got to know, you can't make this stuff. You've got to know your acids. Yeah, this is partly why this is a level 7. Yeah, much harder. Symbol for hydrochloric acid is HCl. Calcium oxide. This is really tough, folks. Yeah, because guys, you've got to build your formula. Calcium is a +2. I know that because it's in group 2. Yeah, oxygen is -2. +1, +2, +3, +3, +4, -4. It swaps over at that point. Yeah, -4. And then you get -3, -2, -1, nothing. So oxygen is a -2. It's much, you see the level jump. Yes, that's -2. So that's now going to be CaO because the numbers cancel out. Wow, what a jump in level this is, folks. Now we've got to build calcium chloride. Calcium is 2+, chloride is a 1-. Yeah, cross and down. I now need CaCl2. And then, of course, we need water. Guys, that is do you see why you can't do this lesson without the previous one? That's why doing those homeworks will be really, really good for you, year 10, super good for you. Now we need to balance it, right? Balance this. So we've now got 1 hydrogen, 2 hydrogens. I've changed something. Start again. Yeah, 2 hydrogens, 2 hydrogens, we're good. 2 chlorines. Oh, 2 chlorines, that's nice. Next, 1 calcium, 1 calcium, 1 oxygen, 1 oxygen. I've finished, look at that. The balancing was the easy bit. Yeah, that's correct now. That was the only number needed. That was the easier bit. The first bit was much, much harder. Yeah, fab. Right, guys, we've got two. Do you know what? I'm going to end the video there today. So what I'm going to do, this is where I go back to this. Go back to, hello! Guys, we're done for the day. Right. I know the last bit will seem very short. It was only the last bit. I know that you've already done this with Miss Holiday. So this is just a kind of a bit of a revision for you. And then before we end up getting into moles eventually and trying to improve that. So what I'm going to do is I'm going to post on the classroom a homework. And the homework, don't worry, the homework is for Thursday. That's 48 hours. If you can't do it in that 48 hours, guys, don't worry about it. Yeah, I'll keep it short. I'll only make it like maybe between 5 and 10 questions. I'll keep it really short. It's good practice if you can get it done. If you can't, don't worry about it. Yeah, you can always then still watch the webinar and go through the answers and then tackle it later on. Yeah, the great thing is about this is the videos are always online. You can watch them back over again. If you just go to my channel, you'll be able to see them. Yeah, if anybody needs any support with how to use the YouTube one, give me a call on Hangouts and I'll always help. Guys, Mr. Duncan, IDT, we have a lesson on. I don't think we have a lesson on Thursday. Oh, no, we don't. That's okay. No problem, Ethan. Thank you for letting me know. Really appreciate that. You're right. I don't think we do. But what I will do is, Miss Khan said this. Yes, that's correct. What I'll do, guys, is I will... the homework can just be for, that's a whole week. Do you know what I might try and do, guys? I don't like missing the lesson. You'll have work set on the classroom, by the way, for the lesson. It'll probably be based on this. But yeah, I guess I'll see you in a week. It's a long time, that. I know. I'm a boomer, Ethan. I don't know what any of these things mean. I don't even know what boomer means. Guys, go and have a great rest of your day. I'll see you soon. Bye now. It's been great to see you. Well done.